Welcome to Formula 1 Maths. This is sample examination question 001 for the AQA Further Maths course. We've got 3 questions to answer. Question 1. Solve the equation square root of 5x minus 2 is equal to. The best thing to do here is to cube both sides of the equation. So you cube this side of the equation and cube 2. So when you do that, you're going to get 5x squared minus 2 is equal to 2 cubed. But 2 cubed is 8. So we end up with 2x minus 2 is equal to 8. Then we take minus 2 to this side and we get 5x is equal to 8 plus 2. But 8 plus 2 is equal to 10. We need x, so we need to take 5, this 5 to the other side, and that means we divide. So when we divide, we're going to get 10 over 5, and 10 over 5 is 2. So that's the solution of the equation. Question 2. Given that this matrix here multiplied by this vector is equal to this vector, work out the value of a and b. You should have read work out the values of a and b. So we multiply out. To multiply, you're going to get 5 times a, that would be 5a, then minus 2 times b, that would be minus 2b. So we are going to get 5a minus 2b. Then for the next one, we are going to get 4 times a plus 1 times b. So we are going to get 4a plus b. And so we get this. But we are told that this one here, this matrix times this vector is equal to this vector. So this will therefore be equal to this vector. And so we equate them. Now the top row will be 5a minus 2b equals to b. This implies that 5a is equal to 3b. Then we can label it as equation 1. Now for the bottom row, this one, we equate them again to get 4a plus b is equal to a plus 2. Then rearrange to make b the subject. So you're going to get 4a plus b equals to a plus 2. If I take 4a to that side, I will be left with b here equals to a minus 4a plus 2. And that will be 2 minus 3a. So that will be b is equal to 2 minus 3a. Let's label that equation 2. Then we go and solve equation 1 and equation 2 simultaneously. What I will do is to take this b and substitute it into the first equation over here. And that's how I got 5a is equal to 3 brackets 2 minus 3a. Then we expand the bracket to get 5a is equal to 6 minus 9a. And then 14a will be equal to 6. We want a, so we are going to divide by 14, and then we simplify to get 3 over 7. So that's the value of a. For b, we are going to substitute the value of a in this equation. So we can get b is equal to this 2 minus the 3, and then instead of the a, we put the value of a here, which is 3 over 7. Work this out, and you're going to get b is equal to 5 over 7. And so the value of b is 5 over 7. Question 3. The point A with x-coordinate minus 4 lies on the curve with equation y equals to x squared plus 4x plus 10. A. Show that the equation of the normal to the curve at A is 4y is equal to x plus 44. The normal to the curve at A also intersect the curve at B. For B, work out the x-coordinate of the point B. We start this question by differentiating the equation of the curve. So dy dx will give 2x plus 4. This is the gradient function of the curve. That means at any point on a curve, you can find the gradient by substituting the x value into this gradient function. So when x equals to minus 4, dy dx is equals to 2 brackets minus 4 plus 4. That simplified gives you minus 4. That means the gradient of the tangent at A is equals to minus 4. That also means that the gradient of the normal at A is 1 over 4. Because if the gradient of the tangent is m, then the gradient of the normal will be minus 1 over m. Because if you multiply the 2, you must get minus 1. So that's why the gradient of the normal is 1 over 4. So the required equation for the normal is given by y is equals to 1 over x plus c. But we need to calculate the value of c. To do that, we need two values, one for x and one for y, of any point on the curve. But we know one point on the curve, which is A, and we know its x-coordinate. We can find the y-coordinate of that point by substituting the x-coordinate into the original equation over here. So when x equals to minus 4, y is equal to 10. That means the coordinate of A is minus 4, 10. We are now in a position to find the value of c by substituting minus 4 into x and 10 into y. So let's do that. And then we simplify that and we get c to be 11. We can now write the equation of the normal as y is equal to 1 over 4x plus 11. But we need to write it in this form. So we multiply every term by 4. And when we do that, we are going to get 4y is equal to x plus 44, which is the required equation over here. There is another way that you can solve this part of the question. I'll show that method at the end of this question. For now, let's go and solve B. For B, we've got the equation of the normal as 4y is equal to x plus 44. We also know the equation of the curve as y is equal to x squared plus 4x plus 10. So if we label them equation 1 and 2, we can go on and solve equations 1 and 2 simultaneously. What I will do is substitute this y into equation 1. So instead of this y here, I'm going to put in x squared plus 4x plus 10. And I get this. I now expand to get 4x squared plus 16x plus 40 is equal to x plus 44. Then I'll take x and plus 44 to this side of the equation. Then I'll get 4x squared plus 16x minus x plus 40 minus 44 equals to 0. If I simplify that, I'll get 4x squared plus 15x minus 4 equals to 0. We now need to factorize this quadratic equation. We can do so by multiplying 4 by minus 4 to get minus 16. Then we must break down minus 16 into two factors to give 15. Yeah. And you can easily see it is 16 and minus 1. So I'll replace the 15x by 16x minus 1x. And we get 4x squared plus 16x minus x minus 4 equals to 0. If I look at this term here and this term, 4x is common. So I factorize 4x out and I'll get x here left from this side and 4 left from that side. In the same way, if I factorize these two, I can bring minus 1 out and I'll get x plus 4. Then we have two terms, that term and that term. The common term between them is x plus 4. So that comes out and we're going to get x plus 4 brackets 4x minus 1. That implies that x plus 4 is equal to 0 or x minus 1 is equal to 0. Solving these will give x equals to minus 4 or x equals to 1/4. But we know that x equals to minus 4 is the x coordinate of A. That implies that the x coordinate of B is 1/4. Now, as I mentioned earlier, there's another way that you could solve this part of question 3a. We know that the gradient of the normal we got is 1/4, and the coordinates of A is minus 4, 10. I'm going to illustrate this by drawing a line like that, but this is not necessary in the exam. Just want to illustrate the method. If I put a general point here and call it x, y, and put the coordinates of A here, minus 4, 10. I have now got these 2 points. I can draw a line here like that and another one here like that. This length here, this length here is y minus 10. And this length here is x minus 4, which is x plus 4. But we know that the gradient of this line here is rise over run, which means y minus 10 over x minus 4. But we know the gradient to be 1/4. So we can equate that to 1/4. Simplify that, you're going to get y minus 10 over x plus 4 is equal to 1/4. If you cross multiply, you're going to get 4 brackets y minus 10 is equal to x plus 4. Then expand the brackets, you get 4y minus 40 is equal to x plus 4. Rearrange, you get 4x equal to x plus 4 plus 40, and simplify, you get 4y is equal to x plus 44. And the same answer we got using the y is equal to mx plus c method. So that's another way you can find the equation of a line when you are given a point on the line and the gradient. So this is the end of this session of sample exam questions. Thank you for watching, and I'll see you in the next video.